Okay, so this is a classic projectile motion problem over here. What we have is we have a cannon on top of a cliff, 100 meters up, shoots a cannonball at 30 meters per second at an angle of 20 degrees with the horizontal. Moves something like this. Question is, what is the horizontal displacement? So how far does it go off from the edge of the cliff? What's the peak height from the ground? So what's the highest point that it reaches? And what's its velocity at 2 seconds? So wherever this ball is, how fast is it going at 2 seconds? Alright, so let's look at this over here. With all projectile motion problems, how you want to start out with is you want to separate everything into X and Y. And personally, what I like to do is I like to start with acceleration. We know that the acceleration in the Y is gravity, so negative 10 meters per second squared. And for acceleration to X, something you need to know is when it comes to projectile motion is there is no acceleration in the X direction. Acceleration in the X direction, no matter what planet you're on, is 0. Okay, so the ball in the X direction always travels with constant velocity. In the Y direction, it's always changing. It's getting less and less and less, and then more and more and more and more. But in the X direction, the velocity is always constant. Okay, so let's see what else we know. We know that the displacement in the Y is going to be falling down 100 meters. Also, but we don't know what the displacement in the X is. That's what we're looking for. So this is what we're looking for. And what else do we now? Well, we can't find that. We know the initial velocity, but let's find what the velocity is in the X direction and what the velocity is in the Y direction. So the velocity initial in the Y is going to be equal to 30 times sine of 20. This turns out to be 10.26 meters per second. Velocity initial in the X is going to be 30 times cosine of 20, which equals to be 28.19 meters per second. Okay, so we're going to put that over here. Velocity initial in the Y equals to be 10.26 meters per second. Velocity initial in the X equals to be 28.19 meters per second. And here we go. Now we have 3 pieces of we're looking for the displacement of X, but we only have 2 pieces of information here. We have 3 pieces of information over here, so we can find out other variables. What's important to know is time is the same for both equations. This is the only thing that's going to be the same. And so if we find the time here, we can also find the time here, and that'll give us 3 variables to solve for change in X. So let's solve for time. What we're going to do, displacement in the Y equals V initial Y t plus 1/2 AY t squared. Negative 100 equals 10.26 t plus 1/2 negative 10 t squared. Let's rearrange this. 0 equals to be negative 5 t squared plus 10.26 t plus 100. If you notice over here, what ends up happening is we have to do a quadratic formula. The quadratic formula being negative b plus or minus b squared minus 4ac over 2a. So let's see. Negative b, I should label this. This is a, this is b, this is c. The one that's t squared is always a. The one that's just t is just b. The one without a variable is c. So negative 10.26 plus or minus 10.26 squared minus 4 times a, negative 5 times c, 100 over 2a. So when you calculate this, you're actually going to get two different answers. One's going to be a positive answer and one's going to be a negative answer. You want to use the one that's a positive answer because there's no such thing as negative time. At least we haven't discovered it yet. So time equals to be 5.61 seconds when you calculate it. And we're going to put that right here. 5.61 seconds. 5.61 seconds. And now, if you notice, we have three pieces of information and we can find change in x. So let's go back over here. Change in x equals v initial xt plus 1/2 axt squared. Change in x equals to b 28.19 5.61 plus 1/2 ax. So important to know here is 0. Okay, 5.61 squared. This whole thing just becomes 0 because there's a 0 there. And then we get our first answer. Our displacement in the x, our horizontal displacement, is 158.15 meters. Alright, so that's part A. Let's go on to part B. Part B is asking for the peak height over here. So what's that meaning is the highest point. So right here, the highest point over here, and what we want to calculate what the highest point is from the ground. So all the way from here to here. Again, we're going to start with making what we know in the x and the y. I always start out with acceleration, 0, -10. What else do we know? V initial in the y is 10.26. V initial in the x is 28.19. Anything else? Okay, so this is initially what it seems like we all know. What we're going to be finding is what is this displacement in the y. So this is what we're looking for, displacement in the y. The one other thing that we need to know is at the highest point, the velocity in the y direction is going to be 0. So it can't go up any higher. So at that instant, the velocity in the y direction, so I'm going to call it v final on the y, equals 0. So that's important to know. So now we have three pieces of information. We can find the fourth. What we're going to be using is v final in the y squared equals v initial y squared plus 2a change in y. 0 equals to be 10.26 squared plus 2 -10 change in y. Once we do this, we find that change in y is going to be equal to be 5.26 meters. But what this is how high it gets from the place it was launched to the highest point. It's not calculating this from the ground, so it was launched 100 meters up. So what we end up having to do is we have to add that 100 meters. 100 plus 5.26 equals to be 105.26 meters. And this is how high it is off the ground. Over here is 5.26. Over here is 100. Okay. Last part, part C. So let's go with part C over here. Start with that x and y again. What we have, ay equals to b -10. Ax equals to be 0. V initial y equals 10.26. V initial x equals to be 28.19. Those are two pieces of information, and velocity at 2 seconds, so t equals to be 2 seconds. T equals to be 2 seconds. Okay, so we have three pieces of information. And let's find what the final velocity is in the x direction, final velocity is in the y direction. So v final y equals to be v initial y plus at. V final y equals to be 10.26 plus negative 10.2, which ends up equaling to be negative 9.74 meters per second, which means it's in its downward direction, so it's probably like somewhere over here. Let's v final in the x is equal to 28.19 plus acceleration is 0 and t is 2, so we still get 28.19 meters per second in the x direction, which makes sense because in the x direction the velocity is constant, as I said at the beginning. At this point over here we're going to make a triangle. So what we're going to do is it's going in the x direction 28.19 meters per second, and the y direction is going down 9.74 meters per second. Combined, this is going to be our final velocity right here. We're going to use Pythagorean theorem and our knowledge of trig to find that our velocity final is going to equal to be 29.83 meters per second at let's find this angle over here, negative 19.06 degrees. All right, and that's how you solve many of the projectile motion problems. Thank you.